This is a short video over the triplot, or triangle plot diagram. And what we're going to do is we're going to set it up as a quick system of A, maybe do a different color, A, B, and C. And in our system, we're going to start off with something that's actually, for this plot, I got to add one thing, and that is the basically it tells us where there are two phases. I should draw a little better. So anywhere in this area, in here, there exists two phases. So if our system is in this area, there are two phases. If it's outside, out here, there's only one phase. So it's just one simple phase. So let's also add the tie lines. And the tie lines are what they sound like. They just tie things together. So this point right here corresponds to that point right there. And you can only get this from experimental values. There's no nice equations you can use, and that's usually why you have to use a triplot or a triangle diagram. So, and these are tie lines. So let's say we have a system that is made up of 40 kilograms of A, 60 kilograms of B. So we're going to mix that with maybe 100 kilograms of C. So first, let's get our original mixture. We have 40 kilograms of A. So we go from 90 to 80 to 70 to 60 to 50 to 40. So that's the 40 kilograms of A. And we have 60 kilograms of B. 60 kilograms of B, so that is 90, 80, 70, 60. So our point is right there where it should be. And then we have pure C, but we have 100 kilograms. But it's just pure, so it's all the way down here. So then what we do is we draw a line between these two. Some type of line. And I don't know if I'm going to be able to do this straight or not. So it's just, oops. So our point should be somewhere on this line. And it'll actually be halfway, because this point represents 100 kilograms, and this point also represents 100 kilograms. So it should be right in the middle, right there. So it should also, after we mix it, we should have 50% C and a combination of A and B at 50% as well. So then our new system is in the two-phase region. So that means it actually has just two phases. It has a phase that is right there, that's its composition is marked right there, and a phase that is marked right there. This phase down here, it is made up of, alright, it has maybe 17% A, and 17% A, 89 or 90, 80, 70, 73, 73% B, and C has about 8%. So I was off by that. So let's just call that about 10%. 10% C. And even though it's probably 8, I must have messed up. Maybe it's 18. So 18% A, and I guess C is actually only 9% C, and 18% A. And this point over here, right there, it is made up of maybe 19% A, 31%, 31% C, and oh, whoops, I'm sorry, I'm completely doing the wrong one. I was doing this point, not this one, so doing that point, so that's 20% A, 20% A, 65% C, and about 15% B, so that was A and C. Now the question is, now that we know the percentages, what's the actual values of those? And we know our system is made up of 200 kilograms after we mix them. So which one has more mass? And it's actually this point, and we're going to call this point E, and this point Q. And we want to actually know the difference in the length of this total line. So what's the length of the tie line? And we compare this length right here and this length right there. And the length of this might be, so we're going to pretend it's, so 1, 2, 3, 4, 4.2. So, and the units are irrelevant. So we'll say that's 4.2. We'll say this other side is 1.3. So then the total length is 5.5. Now the fraction that the phase E makes up of the entire system is 4.2 divided by 5.5. So 4.2 divided by 5.5, that is equal to 5.5, about 76%, and then the 1.3 over 5.5, that should be 24% or about, but let's just make sure, divided by, and yeah, that's about 24%. Oh, 24%. So 24% of our system is Q, and 24% of our, or and 76% of our system is E. So then we'll just do a quarter, so we'll say that's 50 kilograms. So it's actually 48 kilograms for Q. Q has a total mass of 48 kilograms, and that leaves E to equal 152 kilograms. And then what we do to get the actual masses of each component in each phase, we just take 148 times 18% to get the mass of A in component Q, and we get 152 kilograms times 20% for component A, and we just do that for each system. And that is triangle phase diagrams, or triangle diagrams, in a nutshell.